Hey, have you ever wondered how C++ avoids copying large objects to make programs faster? The secret behind this is references. In this part, I'm going to explain everything about references in C++, from the absolute basics to the advanced concepts. Okay, so in a simple, clear way. Okay, so by the end of this part, you will fully understand what references are, how they work, why they exist, and how professionals use them in real world code. Okay, so just grab a cup of coffee, open your editor, and let's master references in C++. So in C++, references is or a reference is simply another name for an existing variable. It does not create a new variable. Instead, it acts as an alias for an already existing one. Okay, so let us see how we can create a reference. Okay, so we say that a reference does not create a new variable. Okay, but instead it acts as an alias for an already existing one. Okay, so we should have an already existing variable. Okay, so for example, let us have a variable called x, and it's an integer or containing 10. Okay, so from there, let us create a reference to x. Okay, so from there, this reference must have the same data type, okay, as the data type it's referencing to, as the variable it's referencing to. So from there, we use the ampersand, because this one is going to get us the memory location of x. These references get us the memory location of a variable. So in order to access the memory location, we use the ampersand. So let us use the ampersand. Then from there, the name, okay, the name of our reference, and let us call it ref. From there, let us give this to x. Okay, so we are getting the memory location and the data there of x, and we are giving ref access to all of that. Okay, so here the ref is the reference to x, which means that a ref and the x are the same memory locations. Okay, are the same memory locations. Okay, so if we change ref, we also change x. Okay, and changing x also changes ref. Okay, so let us take a look at this one. Let us take a look. So if we try to output x, okay, in the first case, when x is still 10, and we try to change ref and we set it to be equals to 20, and from there, let us now output our x like that. So if we try to save and we try to go back in our terminal, we try to compile. From there, we try to run. As you can see, we get 10 and 20. We get 10 and 20. Okay, so this 10 is different and 20 is different. So as you can see, we started with 10 and we changed the ref, which means we also changed the x to get 20, as you can see. So let us take a look at how references work. This is a memory concept, okay, in C. So references do not have their own memory, okay, like normal variables. They point directly to the same memory location as the original value. Okay, so this is why references are so powerful. They allow a direct access to existing data without copying it. Okay, so let us see how we can the knowledge behind declaring a reference. So a reference must be declared using the ampersand symbol here. Okay, so if we don't add that ampersand symbol and we set it like that, it means that this is not a reference, this is a variable, and a variable which is going to contain 10. Okay, and it is going to have a different memory location. Okay, so but if we add an ampersand here, okay, or here, if we add an ampersand or there, okay, there, this becomes a reference. Okay, so we can now start using the reference, our reference like that. Okay, so one important rule is that a reference must be initialized at the time of declaration. Okay, so you must initialize a reference at the same time of declaration. You cannot just do like that. You cannot. this one becomes invalid. As you can see, even VS Code is warning us. Okay, as you can see, this becomes invalid. Okay, so you must initialize it, okay, after declaring it right away. Okay, so that is it. That is the basic knowledge you need to know about references. Okay, and in later parts we are going to see how we can use references, how we can differentiate between references and pointers, how we can work with references and functions and so forth. Okay, even how to use them in loops. Okay, but right now at this level you should just understand what references are. They just point to a memory location of an existing variable. Okay, so let us summarize these important notes. Okay, so a reference must be initialized. Okay, and a reference cannot be changed to refer to another variable. Okay, so for example, here I forgot to talk about that. If we have our reference to x, we cannot change it. So if we have it right there, and we try to create another one, so let us name it y, another variable y, and we set to be 30. From there we cannot change it like this. Okay, so we cannot change it in this way. We cannot say that int, we cannot say that ref, okay, is equals to y. This becomes impossible and invalid. Okay, so as you can see, it's impossible. But even if we say that x, y, like that, so this one becomes invalid also, because we have set it already here. So we cannot reassign it, we cannot change this reference. Okay, so we cannot change it. Okay, so and another rule we need to know is that a reference cannot be null. Okay, we cannot say that ref equals to null like that. This one becomes invalid also. Okay, it becomes invalid. But for the integers, we can say integer y, z, and we can set it to, can we set it to be null? Let us test, guys. So if we do that, let us wait. As you can see, this one is valid. Okay, we can set our int to null. Okay, our z to null. Okay, but for a reference, it cannot be null. Okay, so and another rule I want to talk about before ending this part is that a reference shares memory with its original variable. Okay, I talked about that in the first part. So you need to be knowing all those 4 rules. Okay, you need to be knowing all of them. Okay, so that's it about references. And if you have understood this part, the next other advanced parts about references will not confuse you. Okay, so thank you.